Having the ability to run multiple virtual machines on a server has been a thing now for many, many years. It just makes really efficient use of hardware, where running multiple virtual machines on it can just be way more efficient than trying to run everything on one single operating system installation. Now, with the Raspberry Pi 5, we have a small little single board computer that's got 4 reasonably powerful CPU cores on it and up to 8 GB of memory. And so what we can do is we can try running virtual machines on it to make efficient use of those CPU cores. Let's go and take a look. Hello once again, Pi geeks and techno nerds all around the world. My name's Jeff, and I'm an IT professional who's been in the industry for over 30 years. I've been using Raspberry Pi since they first came out, and I wanted to share with you some of the great projects that I've done over the years. If you like what you see on this channel, please hit that thumbs up button, subscribe if you want to see more, and hit that notification bell so you can be told when I put a new video out. Let me know in the comments how you get on with this project, and if you've got any ideas for projects that you'd like to see me do in the future, put those in there as well. Now, running virtual machines, even on consumer hardware, is nothing new. I've been doing it on my main PC for many, many years now, where I run a Windows virtual machine. It lets me run games and various other software that are otherwise not available on Linux. And I can also make use of advanced techniques such as PCI pass-through to allow me to actually send physical devices such as my graphics card into the virtual machine so that it can make use of it and drive it directly. Now, in the single board computer space, there's typically not been the CPU power or the memory available to really make good use of virtualization. And I'm not exactly convinced that we're there even now. However, in the Raspberry Pi 5, you do have 4 reasonably powerful CPU cores, and you have up to 8 GB of memory. And I frequently find myself running Raspberry Pi OS and then not making efficient use of the CPU. So maybe I'll just be running one particular task on my Pi 5, and most of the time 2 or 3 CPU cores will just be idling. Now, in this day and age, electricity is just becoming more and more expensive, and so we need to find ways that we can make more efficient use of the resources that we've got. So for example, rather than running 2 different Pis, each of which doing a particular job, yet neither of them maximising the resources that they have available, it'd be way more efficient to run a virtual machine on one of them and have that do the second job. That way I only have one Raspberry Pi running, drawing that electricity. And ultimately, the more that you can consolidate down the actual kit that you're actively running, it will save you money in the long term. Now, setting up virtual machines on a Raspberry Pi is really, really easy. There are some gotchas with it. Some things work, some things don't work. But I'll go through that here. Okay, so how do we go about installing a virtual machine on our Raspberry Pi? Well, what I've got here is a Raspberry Pi 5, and I've installed the Raspberry Pi OS 64-bit GUI version of the operating system using Raspberry Pi Imager. I've also brought it up to date using the commands sudo apt update and sudo apt upgrade -y. So I've got all of the latest software on here. Now, the first thing I need to do is actually install the virtual machine software. So in my terminal here, I'm just going to run sudo apt install -y virt-manager. This will install all of the virtual management software and all of its dependencies. It will take a while, so let's just skip to the end. And now all of that's installed, we can go ahead and run it by just clicking on our Raspberry Pi Start button, coming down to System Tools and selecting Virtual Machine Manager. I need to unlock it with my password, and now it's all ready to go. Now, before we can actually create any virtual machines, we need some installation media to set them up from. So this would be just a regular operating system install image. If I go to my browser and I search for Ubuntu ARM64 ISO, then the first search result is Ubuntu for ARM. If I select that and accept the cookies, There's a link here where I can download the Ubuntu server for ARM ISO image. And if I click that, it will just start downloading. Now in a second tab here, I'm actually going to search for another operating system called Alpine Linux. Now Alpine Linux is just a very, very small and lightweight Linux installation that's really perfect for use on virtual machines. Indeed, if I scroll down their downloads page here, there's a version of the image that is specifically designed for virtual machines. So I'm going to download that. Now both of these ISO images are downloaded, we can go ahead and start building our virtual machines. Now the first thing you're going to need to do here is just click this icon. It will come up with a tooltip of create a new virtual machine. Here we want to say that we do want to install it from local install media, because that would be one of our ISO images. And then it takes us to this box where we can actually select the ISO image we want to use. In this case, I'm going to find the Ubuntu one. Here, I just click the button to browse local, navigate to the downloads directory and select the Ubuntu ISO and then hit open. It then needs us to select what type of operating system we're installing. Now for some reason it hasn't picked this up from the ISO, so I need to uncheck this box here and then just type in Ubuntu. Now this hasn't been updated yet to support Ubuntu 24, but there is an option for Ubuntu 22.04. And for our purposes, that's fine. And now just click forward. Yes, we'll correct the permissioning. And now we can choose how much memory and how much CPU resource our little virtual machine is going to get. Now I'm running an 8 GB Pi 5 here. And so I'm going to give this particular virtual machine 2 GB. So I'm going to set this to 2048. And then I want this to have access to 1 CPU core. Now this doesn't sound much, and it's not, but it'll be enough for our purposes here. And then just click forward again. Now we need to create a virtual hard drive, and we just need to provide suitable sizing for that. In this case, I'm going to say that this virtual machine can have a 10 GB hard drive. And again, I know that's not very big, but here I'm only running with a 32 GB SD card in my Pi, so I haven't got a lot of spare room. Now I could attach some USB storage here, I could connect to something over the network, but creating a small virtual drive on the SD card will be fine for this. And here it says it's ready to begin installation. In reality it's not quite, but I'm going to hit finish anyway. And this is why. It pops up this box saying the virtual network is not active. And what does that mean? Well, under the hood, this is using a hypervisor called libvirt KVM. Virt Manager is just a front end to that. Now this has its own networking system built into it, where you can set up kind of virtual network switches that virtual machines can use. Now when you first install libvirt KVM, it doesn't actually start up this networking system, and that's why it's saying it's not running here. But if I just click yes, it will start up. And here we go with the virtual machine starting. It just takes us straight into the Ubuntu installer. So I'm just going to accept here, try or install Ubuntu server. And finally we get here to the install instructions. I'll just say I want to continue in rich mode, select my language, and then just say that I do want to install Ubuntu server. I'll leave all of the networking information alone. I don't want to use a proxy. And then it checks for what are called mirrors. Now, if you're not familiar with the way that Raspberry Pi operating system and Ubuntu operating system package management works, all of the packages that you can download are built into online repositories. And rather than just having a single central repository that you would hit all the time, there's this concept of mirrors where these can be set up globally, and they're just more local copies of the repository that you can go to and access in a much quicker way than the central one. In this case, it's derived from my language settings. I want a British one. And so it's tried out a British mirror, and it said that that's been successful. So now I can just click done on that. Here, this is asking about how do we want to make use of the disk. I'm just going to say use the entire disk by just tabbing down until I get to done and then accepting it. It then gives us this summary of the file system settings, and again, I'll just accept that with done. Yes, I want to continue. And now I need to provide some user information. And now that's all done, I can just hit done. I don't want to enable Ubuntu Pro, so I can just hit continue. I do want to install SSH on this box, so I can hit space to select that and then tab down until I get to done. Here, it provides a list of server software that you would typically install on a new server. If any of this is relevant to you, you can just select it. In my case, I'm just going to pick Docker and then tab down to done. And now the installation will actually start. Now I'm going to move this window off to the side, because while all that's going on, we can actually build our Alpine Linux virtual machine. I come back to our virtual machine manager, click the button again to create a new virtual machine, and follow pretty much the same process as last time. I navigate through, and this time select the Alpine ISO. Just like with Ubuntu, it doesn't matter that this version of Alpine Linux that you can define here isn't exactly the same as what you're installing, as long as it's the right type of operating system. For memory, I'm gonna again give this 2 GB and 1 CPU core. I'll give this a 5 GB hard drive to install onto, and then we're ready to go. Now in this case, you can see it's not actually been able to boot into the ISO image. If you look here, it's brought up this message saying access denied. The reason behind this is because secure boot is enabled for this virtual machine, and we need to turn that off. So just following what it says at the bottom of the page here, I'm going to press any key to enter the boot manager menu. And if I come down into device manager, I can then go to secure boot configuration. If I come down to attempt secure boot, I can then deselect that with the spacebar. It will then bring up a message saying that the configuration has been changed and I need to reset the platform for it to take effect. If I just hit escape to exit and then escape again, I can now come down to reset. So now secure boot is disabled, but the virtual machine is not booting. Now before I can go back into the settings, I need to shut off the virtual machine. So I'm just going to click force off. And now I click this second icon here to show the parameters for this virtual machine. If I come down to the CD-ROM, you can see here that there's no media selected anymore. So I have to click Browse Local, and select our Alpine Linux ISO once again, and hit Apply. I'm then just going to take a look at the boot options, and I can see that SCSI CD-ROM 1 is not selected as a boot device. So I'm going to enable that, and I'll also enable the boot menu. Now let's try starting up the virtual machine again by hitting the Start icon here. And I can go back to the console by hitting this icon. And this time it's booting from the Alpine Linux CD, no problem. Now it gives you a login prompt here, and you can just log in as root with no password. And just following these instructions highlighted here, you can start the installer by running setup-alpine. Here I'll set up the hostname. I do want to use ETH0 as the network ID. The networking will be set up by DHCP, so I can leave that as default. And I don't want to do any manual network configuration. Here I just need to provide a new password for root, and then I can select a time zone. I'm going to leave this as UTC. I don't want to use a proxy, and I'll use Crony for time synchronization. Just like for Ubuntu, Alpine can use mirrors for its package management. So here I'm just going to allow it to determine what the closest and fastest mirror is. I'm not going to bother setting up a separate user here, but I will, just like for Ubuntu, set up OpenSSH. Here it asks if I want the root user to be able to log in using SSH. I'm going to say yes to this. Normally it's not good practice though, and I don't have any predefined SSH key for it. It then asks me what disk I want to install onto, and here we can see our 5 GB virtual disk that we set up earlier. Here it's saying, do we want to use this as our system disk or our data disk? I'm going to say system disk. And now it just asks us if we want to definitely proceed with the installation, to which I'll say yes. And now it'll go off and install Alpine onto the hard drive. Now here we are a little bit later, and both of our virtual machines have completed their installation. Now just before we do reboot here, we need to get rid of the virtual CDs. So if I do this on the Ubuntu machine first, I just hit the icon to bring up all the properties, come down to the CD-ROM device, and then hit the little delete icon, and that will clear everything out. I then just hit apply, and I can go back to the console. I can now just tap down and say reboot now. Similarly, with the Alpine Linux box, I need to remove its virtual CD as well. We just do it in exactly the same way. Now for Alpine, it did just pop up a message saying that it would only take effect after we shut down. So just to satisfy that, I'll shut this virtual machine down with the command power off, and now I can start it up again with the play button. Alpine Linux is now booted no problem. Ubuntu seems to have got a bit stalled on something, so I'm just going to force it off and then start it up again. I'm not sure exactly what went wrong there. Maybe I just ejected the CD too early. And now we have both virtual machines booted. Now we have both of our virtual machines. Let's do something vaguely useful with them. We'll start with the Alpine Linux box. Here, I just log in again as root. And Alpine Linux uses a system called APK as its package management system. So here, I'm just going to install the Apache web server. And I can do that with the command apk add Apache 2. And I can start it with rc-service Apache 2 start. And that started up just fine. So now let's do the same on our Ubuntu virtual machine. Here I log in as PITS. Now since Ubuntu uses apt as its package manager, I can install Apache 2 with sudo apt install -y Apache 2. Now the terminal window handling for this Ubuntu virtual machine isn't great, so I'm just going to hit Ctrl L to clear the screen again. And now I can start up Apache with sudo systemctl start Apache 2. And I can check it's running with sudo systemctl status Apache 2. And that appears to be running just fine. So now we should be able to access these web servers. But in order to know what to access, we need to know their IP address. Again, let's start with the Alpine VM. If I clear the screen and I type in IP add show, this will show me the IP address that has been assigned to this virtual machine by the libvirt KVM software. In this case, 192.168.122.55. Now let's do the same thing on the Ubuntu VM. And here you can see it's been given the IP address 192.168.122.66. So now if I open a browser and I navigate to the 122.55 address, you can see that I get the It Works message back from our Alpine Linux web server. And if I do the same thing on a new tab and go to the 122.66 address, you can see that I get the Apache 2 page from our Ubuntu server. So this is great. Everything's working. If I bring up a terminal and run htop, you can see there's not actually an awful lot of load on the Raspberry Pi 5. These virtual machines are actually quite lightweight, even though they're running fully fledged operating systems themselves. Now each one at most could consume one CPU core, so they're never going to overload the machine entirely. And that's one thing with virtualization that you always need to be aware of. You can't afford to allocate more resource than the host system has to give. Otherwise, you'll just see your host system grind to a halt and you won't be able to do anything with it. So there you go. Now we've been able to create a couple of virtual machines on a Raspberry Pi 5. And they're running really effectively. But where do we go from here? Well, you could see that I was able to access those web pages from the Raspberry Pi itself. However, because they're on a completely different subnet, I've no way of getting to those virtual machine web servers from the rest of my network, let alone outside the network. Now, in order to enable this, you have to set up something that's called bridge networking. And this is a bit of a complex thing in itself. And so I'll cover that in a separate video. Now, the other thing that I have tried and I've not been able to succeed with is installing something that is completely not Linux related as a virtual machine on a Pi 5. Rather than the Alpine and Ubuntu ISO images that I downloaded previously, I tried to use the Lineage OS disk image that you can get from the Constacang website. Now, even though this is capable of running on an ARM64 platform such as the Raspberry Pi 5, it is actually an Android-based operating system. And I thought it'd be really interesting to be able to see Android running in a virtual machine. However, I've not been able to get this to work. Initially, I had the same problem as I had with Alpine Linux with Secure Boot, and I had to disable that. But even when I did that, it still wouldn't boot into the installer. And I don't know why. This is a bit odd. I also tried out the Windows on Raspberry project. Now, WOR isn't great as it stands right now. Technically, you can get Windows to run on a Raspberry Pi 5, but none of the networking supports, other devices don't work, and it's generally a pain to do anything useful with it. And it's another one where I certainly couldn't get it to install on a virtual machine. But with both of these, I will keep on trying, and if I have any success, I'll let you all know later. But that's it for this video. Once again, if you like what you see here, please hit that thumbs up button, subscribe if you want to see more, and hit that notification bell so you can be told when I put a new video out. Let me know in the comments how you get on running virtual machines on your Raspberry Pi. And as always, if you've got any ideas for other projects you'd like to see me do, put those in there as well. Thanks so much for watching till the end, and until next time, bye for now.